So I'm going to be talking about performance metrics in Deephaven and how a user can access their metrics. The first thing I'm going to do a quick overview on how real-time updating works in Deephaven. So the data flow is represented by what's called a directed acyclic graph. So that just means there's no loops. The code to the right here creates this right chart, and you can see with the arrows how the data flows here. It's just going to flow from the sources all the way through the graph. The engine's smart, so it's only going to try to recompute rows that have actually changed when it does these updates. And the updates are batched, so it's configurable, but the default is going to be every second. If your query looks sluggish and the data in your tables is updating every 5 minutes, one of the things that could be going wrong is that you have long LTM cycles. So an LTM cycle is a live table monitor cycle. And these can be found in the Docker server logs. So the image below is an example of what that looks like. So in my sample query, these are pretty quick. 50 to 100 milliseconds about.
I'll note that LTM is now UGP, update graph processor.
Yes. So if you're seeing slow UPG or slow query initialization, or you just want to see how your metrics are, these can be accessed with the table loggers package. These allow users to really quickly just see these metrics and pull these up. One of the top ones, this is the one that I personally use probably the most, is the update performance log. So this will give information on those incremental real-time updates. If your query is updating slower than you might expect, this could be a place to start. You would look at the entry description column to give you information on what query operation it is. So for example, we have an as of join, we have an aggregation, we have an update. The way I've typically used this is you would filter to a certain interval. These are aggregated into bins, maybe a second long or a minute long. And then you could sort by the entry interval usage. So that would give you the top offenders and maybe the top query operations that you would need to look at the beginning of your analysis. And I already explained this. So this also includes some internal query operations like this exported table update listener. If you look at the entry caller line, it can give you an idea of whether it's an internal operation or something from your query or a user operation. I think I've talked about most of this. So in this example, it was a pretty simple query. It's just a aggregation, joining on some data and some plots. And in this example, I've sorted by entry interval usage to get those top offenders. And you can see that it's the plot, which is the downsample listener, our join and our aggregation and our update are a little more performant. So maybe the plot is where we would look to first attack the performance in this example. The update performance log also has some other columns. So these are the entry interval added, modified, shifted, and removed. So this tells you how many rows in the interval changed. So in this example, we had 330 rows added to our plot, and that's how many rows we had to recalculate to create that plot. When you're diagnosing your performance, sometimes you can think that, hey, I should only have 100 rows a second. I look at my UPL, my update performance log, and it's telling me I'm having 7,000 rows changed a second. Excuse me. And that could tell you, hey, my join is causing my entire table to recalculate. I need to shift my query around so I'm recomputing fewer rows. The other table I use all the time, query operation performance log. This will give you information on initialization times as well as memory usage of each operation. So if your query is taking a little longer than you expect to initialize, this could be a place to check. Here I've sorted by the column duration nanos. I have the description column, which is describing which query operation is assigned for that row. So here, the top two initialization in my query were an update, which took about 8 seconds, and an aggregation, which took about 7. So if I were to go into this query and try to improve initialization time, those would be the two places that I might start because those take up the majority of the initialization time. This also tells you the memory change as well as that duration. So those columns are the free memory change and the total memory change. So the difference there is free memory is the amount already in the JVM that's allocated for new objects. So for example, this update didn't change how much memory was taken up by the process itself, but it took up 90 megabytes of that free memory. The total memory just describes how much is allocated to the whole JVM. There's also this process metrics log. This can give you insight into like process statistics such as page faults, heap used, etc. The process info log would give you configurations, JVM parameters such as your class path, your configuration root file. This would be a way to check to make sure that your application is configured as you expect. And then we have the process memory log. This quick way to see the total and free memory available to the process. So this was updating once every 15 seconds about, giving updates on how much memory I'm taking up. And that was it.
Can you talk a little bit about the internal operations and how to think about them and when to use them or not use them?
Sure. So you're talking about the update performance log or something
Yeah,
else?
a couple of these logs have things marked as internal.
So I think this internal, like, I think it would be hard for a user to necessarily know, like what is the exported table update listener? Um, so I think for users, they're going to want to look at their own user queries, query operations, I should say. So in that case, that would have that entry caller line that doesn't say internal. In this example, I was able to look up what this downsample did because it was the top offender in the documentation. I think in general, these internal ones are not going to be what users want to focus on. They want to focus on their own query lines. Did that answer your question?
Yeah. Right. Any other questions for Devon? Or
So
comments?
if a user looks in, these performance logs and sees a problematic query, what would the user want to do to take steps to alleviate that or to make that better?
Okay. I mean, I guess it depends on what you mean by problematic. So
Like if it's taking too much time or doing too many row updates.
too many row updates. So that's when I would use this update performance log. So that's the real-time updating log that's giving you the metrics on what each operation's actually doing, over the interval. So this will be, I guess the way that I've done it is I want to look at the top I call it the top offenders here. So that's just the ones that are taking up the most time. So if I optimize, the bottom here, this sort took about 22 seconds out of my interval. If I go through a lot of effort to optimize the sort, I'm not going to get as much as if I did the top three here that were way higher. So to me, I would go to the update performance log and I would see, okay, my as of join here. That's something I could think about. So each of these maybe has a different way to think about it. So maybe an update you could replace with an update view. Maybe it makes sense in your query to filter down some data and downsample. Maybe it makes sense to, um, you know, restructure it so joins are later and you're joining on less data. Um, I think it really depends on the operations that you see in this top offenders.
To follow up on
Cool.
that, are there
Thanks.
any like usual suspects for things that tend to bog down query performance, or is it highly variable depending on use case?
I think it's pretty variable, but at least in the use cases I've worked with, it's generally been aggregations. I mean, just like in this example, it's generally been aggregations and updates. Um, and in that case, that can just be because of these really complex formulas and updates and how many rows are ticking. So you'd need to look at, your entry modified, entry whatever, all these rows are changing. If you're getting way more rows changing than you expect, maybe that could be something to look at. If your formulas are really slow, then the updates are going to be slow. So that could be something else to look at.
And if the difference between update and update view can also be huge. If you're just looking at a small subset of the data, you may be computing things you don't need.
Yeah, and you can do some of these things in a lazy fashion that you don't necessarily need to do an update. Could have changed it to an update view.
Yeah, I think that idea of update versus update view, you should be mindful of. Like sometimes it makes sense if you're going to use a table a lot to use an update. So it can work the opposite way from what Devin just described. One, two, my usually performance relates to a lot of new ticks. So when something is expensive, usually there is a lot of ticking data. And the concept of tick proliferation, where, oh, you have a table, you think it's getting 100,000 ticks a second, but because of the way your query is organized, you're actually getting 10 million ticks a second. That happens a lot. Um, and, typically that'll be what really kills query performance. The other thing is for this group, I think, to the extent that you're not smartly moving across the Java to Python boundary and you're doing Python driven calculations, and if they're not vectorized, well, then that could be pretty expensive too. I don't know if people have great examples of tick proliferation. I mean, if Andy or Rafi or, maybe Devin can speak to examples of when that happens.
Yeah, I mean, we had a case with a client that was doing wanting to do AI calculations, and the market was ticking, once every millisecond or less than that, and their AI calculations couldn't keep up. And so in that case, we snapshotted the data so that it was every 100 milliseconds it would recompute. So you have cases like that.